This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio brings you relevant and detailed discussions of software engineering topics at least once a month. SE Radio is brought to you by IEEE Software Magazine, online at computer.org/software.
For Software Engineering Radio, this is Robert Blumen. I'm here at the beautiful downtown San Francisco offices of Loggly with Jon Gifford. Jon is a graduate of the University of Canterbury in computer science. He's been active in the software engineering field for over 25 years, focusing on high-performance, large-scale back-end systems, and, more recently, search applications with low latency. He is the founder and chief search officer of Loggly, a company that provides hosted logging infrastructure. Jon, welcome to Software Engineering Radio.
Thanks, Robert. It's great to be here.
Jon and I will be talking today about logging and logging infrastructure. Jon, we've done a ton of shows about how to design software, test it, build it, great processes for your teams, but at some point you have to run it.
Yeah, and that's kind of where logging comes in, I think. So I've been, when you have spent a lot of time writing software, logging is one of those things that I think is a little bit like documentation for a lot of people. Seems like a really good idea, but it's always the thing that kind of falls through the cracks unless you're fairly diligent about it. So that's, it's kind of the red-headed stepchild of software development.
So what is logging?
So I think it's a lot of different things. I think that, at the simplest level, it is just sort of the sort of status messages and things you get from, kernel or kernel drivers, very terse, very opaque. You need to know you need a decoder ring to figure out what they're telling you. Anything from there up to sort of very highly structured metrics, performance data, and it can even be, and we see a lot of this, it can just be sort of stream of consciousness from the programmer. It's like, it's interesting to look at log files and look for profanity, and you usually know you're somewhere interesting in the system when you see profanity in the logs. So lots of different things.
We don't want to lose our family-friendly rating on iTunes, so I won't ask you for any examples.
I'm sure engineers know lots of things to search for.
Next, I'm going to do something which is generally considered a bad idea in an interview, but these 4 questions seem to me to be so closely related that I'm going to ask you 4 questions all at once. You've answered the first one a little bit. What is the content of logs? What parts of the system produce logs? Who are the consumers of logs? And for what purposes are logs produced?
So yeah, they are all very tightly kind of coupled with one another. I think that at least when you think of typical logs, you think of system and application logs, and application in that case is applications that you write, or they're applications third-party, open source, or commercial software, all log to varying levels. And the fact that logging has kind of a long history has meant that there are all sorts of different uses for it. So, if you're used to dealing with Java, which I've spent a lot of time in, you have frameworks that let you generate logs that are designed primarily for humans to read. So if you're writing a piece of Java and you detect something sort of interesting, maybe you'll log it as an info level. If you notice something interesting and bad, you might log it as a warn. If you notice something very bad, you might log it as an error. So, I think that there's a best practice, maybe is the right way to think of it in logging, to try and guide you in what to omit. But you do kind of have to think of your audience when you're logging. And I think that for most application developers, the consumer is themselves, so they know that when, like the profanity example, for example, they know they're in a particularly gnarly bit of code. They know that maybe it's difficult to test or even impossible to test, but they do want to know what's going on. So they're going to be logging for themselves and dumping as much information as they have to try and sort of understand what's going on. I think that. So the contents of logs can be anything that is going to help the person who is running the system understand what's going on. I mean, one way of thinking about it is, in a perfect world, you'd be able to attach GDB or a profiler or a coverage tool to everything that's running in production. But most people don't have that much money. So logs are a way of getting insight into what is happening without having full access to what's happening. In a sense, it's kind of in some ways it's the inner voice of your application trying to help you understand what it's doing. And so I think the main purpose of most logging is exactly that. It's trying to explain what's going on, and that explanation could be as simple as I received a request and I served it. Apache is a great example of that. Here's what the request was, here's how long it took, here's my response, that kind of stuff, like the stuff that anyone who's ever run a web server knows kind of intimately from looking at Apache logs. And that lets you, by the way, sort of understand how your system as a whole is performing, I guess. But it can also be things like we, for example, have lots of metrics in our code. We want to understand how data is flowing through the system. We want to understand how the system is performing. So we log insane amounts of performance metrics. And they look very different. Those two things look very different, but they kind of serve the same purpose, which is that it lets us get insight into what the application is doing. So I think that, if you boil it all down, it's your application is telling you what it's doing.
Great. Now, you've explained that logging is something programmers do as part of creating a program. Could you talk a little bit about what is the programming model for logs? What do developers code against in order to produce log information?
So I think there's lots of different ways you can do this. I mean, the famous printf hello world in some sense is logging. But I think that these days people tend to use frameworks. In Java, it's log4j. Every sort of modern programming language has a logging framework. And they kind of take care of the stuff that is kind of annoying to deal with. So, you want a timestamp, you want a severity or a level for your message, you want potentially, the thread name, you want potentially the method name, and then you want a message, right? And the frameworks are the things that make the first of those kind of invisible to you. You just use it. You just say log this, and your log contains all of that other, I guess you could call it metadata. And you don't have to really do much to do that. I think if you find yourself writing log messages to standard error or standard out, you're probably doing something wrong. Like there are good frameworks for every language, and you should use them.
Developers often do use these frameworks to write log messages. The thought has occurred to me that a lot of things that get logged, like this method got called, you could have either part of the language runtime or an aspect-oriented framework like Aspect-J or Spring AOP that could do a lot of logging for you. and avoid the tangling of log messages with application code. What is your view on, should we be relying more on aspect type or frameworks to do a lot of our logging for us, or should we be doing it right in the code?
So I think that there's absolutely advantages to letting the framework do all the work for you. There are some things that you simply can't get around doing it yourself, but if you can get useful logging essentially for free, you should get it. I mean, I think there's this is one of those things where I have had some interesting kind of debates with coworkers. I'm of the belief that you should log as much as you can, and you should do that because you can't diagnose a problem without data. And so if you forgot to log something and it's not in the log, you're not even going to know that it's not there. And so you're kind of, I hate to get all Rumsfeldy, but there's unknown unknowns going on. If you log more than you think you should, the chances are you'll find that you're actually logging the stuff that matters at some point. And one of the tricky things, software is a tricky domain, and distributed systems particularly are very tricky. If you're not logging it, you're not going to know it's happening. So I'm a firm believer in log way too much, and I don't see a downside. People can argue about performance. I personally think that if your logging framework is your biggest performance hog, then you're probably in a pretty good place because your problem is probably pretty small anyway. So, I think that there's more is better.
You talked about some structured type fields that would appear in a log, like a timestamp. There could be IP address of the machine where the node runs. I've seen a lot of logs which each developer writes a very wordy message with information however they feel like expressing it. It's occurred to, and then you got somebody else at the other end who has to parse and try to remember. So should we be writing logs out in more of a structured format that can be parsed easily, like a JSON or XML?
So I think that for the vast majority of logs, the answer to that is yes, unequivocally. I think that there are a lot of tools out there, including us, that will let you sort of extract more value from structured data than from just text. And I think that one way of thinking about this is that if you were comfortable writing a custom grep followed by some sed, followed by some awk or Perl or Python or whatever, every time you wanted to do anything with your logs, then sure, don't worry about it. But I think that one of the things about logs is that they contain real data. They contain latencies, they contain, paths, they contain, file sizes, they contain a lot of incredibly useful structured data. If you then just kind of slam them all into a piece of text, and I'm as guilty of this as anyone on the planet, if you just slam them into a sentence, then it's much harder to deal with them, and it's much harder to kind of correlate, sentence A with sentence B. If you put a bit of effort into structuring, then you end up with the ability to say, oh, actually those two messages are related to one another, and they're telling me that something broke or something went well. So I think that we encourage people to send us JSON, and I think every logging platform on the planet is based on the assumption that computers can deal with 80 million log lines better than you. And I think that anyone who's ever had to deal with, a couple of 100 gigabytes of logs per day is going to say, yeah, I don't want to do that by hand. So, what you need to think about is who's consuming it, or actually what is consuming it. And if your consumer is a computer, then make it easy for the computer. Because if the tool works and gives you what you need, then the fact that you end up with stuff that is a little harder for you to parse as a human is kind of irrelevant, because actually what you get out the other end, if you put it in essentially any other system, is far more valuable.
Logs in the past used to be written to files. We're moving away from that, and I'm going to talk about that, but talk a little bit about the architecture of the file-based logging, what the workflow was, how files were processed.
Yeah, so this goes back to grep and sed and awk and perl and GNU plot. I think that files are fine. I mean, the file system is probably one of the most robust abstractions anyone's ever come up with, and there's nothing wrong with logging to a file. The problem is that these days it just doesn't scale. It doesn't scale in a lot of different ways. So, for example, if you're on EC2 and you have instances that come and go, then if you're not careful, when they go, so do all your logs. So you then need to start thinking about, so I need a pre-shutdown script that will grab all the logs and put them somewhere else. And, all of those kind of issues are just a pain when you're dealing with even fairly small numbers of machines. You need to start thinking about, if a machine is ephemeral, then what does that mean for the logs on that machine? And some of them are completely ephemeral. I mean, like the system log on a machine that you spun up and ran for a day and shut down is possibly completely worthless if the machine performed the way you expected it to perform. But, I think that application logs on that machine are probably not. They're probably something that you want to get, and you want to make sure that the machine actually did what it was meant to do. So there's that side of it. There's also, I think, just there are the things that everyone does. Funnily enough, we do it ourselves here to this day, which is, if you don't get your log rotation strategy right, you blow up machines. They stop working because they suddenly run out of disk because the disk is full of logs. And I think that there are a lot of tools that let you do log rotation and log expiry and blah blah blah, but you're dealing with adding a layer of tools to deal with a problem that in some ways these days just shouldn't even exist. Like, you should get the logs off the machine, you get them somewhere central, and not worry about it.
You didn't mention what I think is one of the biggest problems with files is, if I'm looking for something, I have to wait for spinning drive to do a lot of rotations before it gets to the record I might want to find.
That is true. I mean, I guess that's why there's fgrep as well as grep, right? I think that in the same way that there are better technologies for sort of analyzing your data than sed and awk and friends, there are better technologies for finding it. And, search engines are the prime example of that. I mean, if I know that my Java application is logging exceptions, it's much easier to search for it in a search engine than it is to go and look for it in one of potentially many hundreds or thousands of files. And I think that it's one of those things where people don't understand the power of that until they actually sort of see it in action. People are used to Google. They're used to search being really fast. But ironically enough, they don't think that that same kind of power should apply to looking at logs on a machine, right? They're sysadmins, DevOps, developers are happy to log into a machine and then find the file or look around for the file or whatever, and then try to extract stuff from it. And it's a hard habit to break. So I think that part of the challenge is getting people to understand that there are better tools out there, and you should just use them.
Where you're going with that is toward my next question, which is the modern log architecture based on a network and a search engine. Tell us about the history of the modern log architecture and describe how a modern logging infrastructure works.
So I think it's an evolution. I think in the Unix world, at least, syslog has been around forever. And syslog has always had this idea of sort of forwarding your logs to an aggregator, I guess. And I think that there's very good reason for that, and it's to do with the stuff that I was talking about before, which is disks filling up and being able to go to a single central place. So I think that the idea that every log in your entire ecosystem is in one place is incredibly powerful, and I think that people who take logs seriously have always kind of adopted that approach using whatever technology was available, and primarily that was stuff like syslog or rsync or all of the typical tools that you use to kind of move files around a network. But in the end, you're still dealing with moving files around a network, and you're still dealing with having to use fairly primitive tools like grep to find stuff. I think that the idea that you aggregate into a search engine is the big revolution that's happened in the last few years. So it started with Splunk, and I think people kind of got an understanding that once you have all this stuff in one place, you can do more with it than you could ever do sort of when it's distributed, or even when it's gathered but in separate files. When it's an homogeneous, when you have a single interface to all of your log data, you can do things to it that you simply can't do easily any other way. And I think that search provides a vastly more powerful. The language of search is much more expressive than the language of grep. Or the power of grep, and I think that it's one of those things. We are used to thinking in terms of regexes if you're used to dealing with files, because regexes are a powerful way of finding what you want in a file that could contain all sorts of stuff. Regexes are one of those things where, if you know what you're doing, they are incredibly powerful and they are incredibly useful. The problem is that I think that a lot of people think they know how to use regexes and don't really know, and then they sort of end up wasting a lot of time trying to get just the right regex to find something, and they would be better off using a tool that is explicitly designed to find stuff, which is a search engine. So and these days, search engines are more than just grep. They are, in a lot of ways, you can think of modern search engines as much about analytics as they are about sort of finding things. So Lucene, for example, has native statistical analysis that you can run. You do a search which narrows down the documents that you want to run the statistics on, and then you run the statistics on a specific field within the document. So you get this incredibly powerful analytics engine built on top of something that, quite frankly, people don't understand the full power of.
We talked about, you've got your structured type fields like a timestamp and a node and maybe user account. Then you've got the Lucene, which gives you the full text index, so you can start querying. Is this opening up a domain for the analytics type professional now to become an expert in log data and to extract business value from that data using the database-like querying capabilities?
Absolutely. I mean, I think that if you're coming from a traditional sort of relational database background, it's a little daunting. The language is different, obviously, and the repertoire of tools that you have available is a little more limited. Like, quite honestly, it's more limited than you might be used to. But yes, and I think that one way that I've been kind of describing search lately is when you have a distributed index, meaning it's sharded across 10 or 100 or 1,000 machines, you can think of search. You can think of a search engine as kind of a micro MapReduce engine rather than just a search engine. So because what's going on under the covers is you execute the search, it identifies the documents that match, and then it streams those documents across something. Like, simplest case, it streams it across a scorer and decides whether it's a good enough document to return to you because it scores more highly than other documents. But that streaming is happening in parallel across all of the data in your entire index simultaneously, and you can execute code on each document as it goes by, right? So, as an example, if you have Apache logs and you have both the latency for the request and the size of the returned page, then you can calculate sort of bytes returned per millisecond of latency for the request, right? Which is a derived value from the actual log message that you can't get directly from it. I mean, if you wanted to write some awk, you could do that, but but you can do it in parallel across everything and then do statistics on it, right? Do min and max and standard deviation, all of those kind of things can be done on that data which you're synthesizing as the documents are kind of streaming across this. You can think of it like a tape recorder. So they're streaming across this head, and the head is just pulling what it wants. So
it's very powerful.
Yeah.
Now that log is a distributed system, you've got your search index, which may be distributed to other server processes to ingest the messages. One of the primary purposes of logging is to debug and troubleshoot the system. So doesn't this now introduce a whole range of error modes? My firewall's not configured to let the messages through, or
it does.
This node is down, and how do you figure? So yeah, sort of see what
Yeah. I mean, it's interesting. So we have, and this is, I'm sure this is true of anyone who builds any distributed system. We have, or any system at all for that matter, but distributed systems particularly. We have this interesting kind of recursion going on, which is we have a distributed system that is solving a problem, and when things go wrong, the way we know that they have gone wrong is essentially through the logs, which are fed into the system itself so that we can diagnose the problems in the system, right? And we are kind of obsessed with availability, I guess is one way of putting it. We know instantaneously when we have, there are big things like a node drops out of the cluster, but there are smaller things like, an update to a node isn't available yet, and so we get inconsistencies in the search results. All of that stuff is kind of stuff that we log and then feed into the system so that we can detect these problems. But yeah, there's definitely a little bit of a chicken or the egg thing there for us, and it's really important to us. The most important thing to us is that we don't lose data. So even if there is a problem in the system, it's I'd like to say self-healing. Every now and then we have to step in and fix things, but it's definitely sort of heading in that direction. And I think that there are lots of ways that you can use a system that takes logs and tries to figure out what's going on from them, and then allows you to use a mechanism like alerting, for example, to call some REST endpoint somewhere else that would kind of allow us to build a completely self-healing system in sometime in the future. So I think that, it's interesting. It's a challenge, but I think that, the deeper we get into the kind of use cases for our system, the more those use cases surface for us as well. So,
are you seeing people adding another network interface to their nodes so that they can send log records to the log servers and not compete on bandwidth with serving application data to end users?
So typically, no. Typically, I think, in the same way that if your logging framework is chewing up massive amounts of CPU, if your logging output is chewing up your network, you've probably got other things to worry about. So typically, no. I think that we don't typically see huge amounts of data from a single machine. Obviously, when you have hundreds or thousands of machines, then the aggregate is large, but that typically doesn't affect our customers' applications. I mean, it's kind of noise. Maybe they're chewing up 5% or 10% of their network on logging, but it's not a significant cause of sort of grief for anyone that we've heard from so far.
How much space is a typical application? There's such thing, or maybe you could give some sizing parameters for an application, and then how much gigs or terabytes or space of log records would be common.
So we we get a lot of data. I think the answer to that is that it's kind of a zip curve, right? So there are some applications that generate a lot of logs, and a long tail of applications that don't generate much. And there are a number of customers who generate a lot of logs, and a long tail of customers who don't. And so it's kind of difficult to say anything very general about it. But I think that, a typical log message for us is, I think, probably in the 0.5K to 1K range. That's a little skewed because we encourage people to send JSON. JSON is verbose. But, I think if we were to break it down to logs that people have control over versus logs they don't have control over, there's a definite skew. The stuff that you don't have control over, so system logs, open source or commercial products that you use, those kind of things, typically the log messages are smaller because they're typically written so that the logs are consumable by humans, whereas I think a lot of people these days are writing logs to be consumed by machines, and so they're more verbose and so therefore larger. But you could think the old style logging, I guess, you're looking at 200, 300, 400 bytes, and the new style ones are sort of in the 1K plus range. So we have some customers who are sending us 100K messages or 200K messages, and that's fine. I mean, if that's what it takes to capture the amount of data you want to log, then log it.
You mentioned data you didn't produce, like a database server that you run, but you didn't write. Is there an intermediary step where you pull the logs out of wherever that server decided it was going to put them, and then you transfer them into whatever kind of JSON or format?
Yeah, so I think that there's a couple different ways of solving this problem. So and it depends on the product you're using. What we do is we support a bunch of standard formats. So I've already mentioned Apache, but there's probably 10 or 15 or 20 other standard formats, like database formats, right? And you can just ship them straight to us, and we will parse them and do the right thing. There's a separate approach, which is to write something yourself, and we actually do this for stuff that is very, very simple. So, for example, we were having some problems with Zookeeper. Zookeeper is an awesome Apache project, but their logs are text, they're sentences. And so basically what we did was we just wrote a tail on the file and looked for, there was a specific message that we were looking for about f-syncing the log file, and it was a warning that the f-sync took too long. So we just tailed, grabbed, and then extracted the value and using Logger, just logged it to ourselves. So, that's one thing you can do. It's a little, it's not something I would recommend that you invest heavily in, because there's a lot of things that could go wrong and you could end up spending a lot of time on it. There's a third approach, which is to use something like Logstash, which is I guess one way of thinking about it is it's kind of an ETL for any data. And it has a lot of different sources and a lot of different syncs. You can read the file into Logstash, define some rules in Logstash to emit whatever structured data you want, and then pass that off to us. So I think, there are, other products, other different products have agents which can do some of this for you. And I think that it's really the question there is, what do you want running on your machines just to solve this problem? And we've gone with the approach that you don't want anything. Syslog is across the board, and everyone's comfortable with it. So our approach is just ship it to us and we'll sort it out. If you want to do it yourself, you can certainly do that, but you're adding extra load to your systems that you could potentially avoid. So,
in looking at this modern logging architecture, a question comes to mind. Back in the old days, there was your business data. You put that in a real database which had columns, and it was highly monitored, and it was backed up, and you did a lot. Yep. You were willing to incur a lot of expense to ensure that you would never lose data, and it would be highly available. Then there was this very robust file-based logging, and if you lost a file, well, it was just log data, and it was not necessarily it was pretty reliable in getting it from the program to the file, but files, different things can happen to them. Now we've got logging, which is going into a database, and from what you said, you're very obsessive about ensuring that this database never loses data, and it's got columns and the structured fields, and you've got a network protocol. And at some point, have we arrived at this world where everything is in a database and there are just different types of databases that are optimized for different types of data, and that hard distinction between the important data and the unimportant data doesn't apply anymore?
I think we're getting there. I mean, I think that one of the things that has always appealed to me about logs is that they have a really important piece of metadata associated with them that a lot of other data doesn't, and that's the timestamp, right? So one way of thinking about all log analytics systems is that they are really time series databases, right? And then on top of that, they're real time, and on top of that, they're actually analytics systems more than just search systems. So I think that for specific kinds of data, that's the best fit. I mean, I wouldn't suggest that people dump their 15 petabyte Oracle database and spin up Elasticsearch, because, like I said, there are some things that you simply can't do. but I do think that that boundary is blurring, and I think that we see this in logs. This kind of goes back to what's the content of the logs. If you have this real-time time series database that supports analytics on semi-structured data, then you can use that to solve problems that are not the same kind of problems that you would solve just using logs. And I think that we see customers who do this. We have customers who send us data that is not strictly speaking logging data, because they can then use our system to do the analytics that they want to do on that data. So I think that the lines are blurring. I think that there's this really interesting continuum of technologies out there. And the reason I mentioned earlier that, to me, search is kind of a micro map reduce is that I think people are really these days kind of really familiar with MapReduce as a way of solving certain problems, right? And so you have this, and then there's the whole NoSQL thing with Cassandra and CouchDB and you name it. And then there's traditional relational databases, and then there's, every other sort of data store technology out there has, I think, its own strengths, and I think you should use the right one. But I think that it's often surprising to people when they sort of sit down and think about what they could do with something that is time based and something that is real time, as distinguished from a more traditional database thing, and even from something like Hadoop. Like the problems you solve differently, and some of the problems fit nicely and some don't. So I think that's a long-winded way of saying use the right tool.
There are two of what you might call business models in the logging space. There's open source tools like Graylog, and then there's the hosted logging as a service that Loggly and Sumo and Splunk. What would be a good thought process for the capacity planner or the IT architect in trying to get his system on the right platform?
So I think that there's a couple things here. One is that this stuff is just fun. So if you want to have fun and you don't have any hard constraints, then by all means go sort of grab Graylog, Elk, Silk, whatever it is, or any of the open source things, and play around with it. I think that there's a lot to learn, and you will have a lot of fun doing that. I think, though, that purely from a business point of view, sort of the way I look at it is, for some things, blah as a service makes a lot more sense. I think that you can go and you can grab these open source tools and you can get them up and running, and you can usually get them up and running pretty fast. I mean, I'm not trying to pretend that they're hugely complicated or hugely expensive or anything like that, but I think that you will find that over time you end up investing time in them, right? That you don't necessarily get back. And I think that, it's the same argument for why don't I just host my own mail server, right? Sure, you can do it, but Gmail does it, right? And so do 1,000 other companies, and they do it better than you ever could do it. So for me, for us, it's that argument. I don't think people fully understand how much time you need to spend with these systems to get them to do what you want them to do. Frankly, I think that the fact that there are a lot of companies in the space means that the commercial products are evolving very, very, very quickly. When you have a team like we do of 25 people, and all we think about is how to deal with logs, the chances that you will be able to do a better job than us becoming less and less. I think even the purely open source stuff, the chances that someone has already kind of solved the problem that you have is it's not impossible, but I think that there's a critical mass that needs to happen in an open source project where it really snowballs. And so everyone has Apache logs, so Apache logs are dealt with in all the open source projects. But maybe not everyone has Zookeeper, for example. So maybe Zookeeper is not dealt with. And I think that there's a certain benefit to, in some ways, just paying someone else to solve the problem for you. It's what
it's
it kind
not
of boils.
core to what you do.
Yeah, I mean, like I said, if you have no hard constraints, you have endless time and endless money, go do it. It's a lot of fun. I highly recommend it. But you probably have better things to do with your time.
Talk about the type of interfaces that become available for looking at the log data once you've collected it in a system.
Yeah, so I think this is one of those things that that is incredibly important when you're dealing with whether you're dealing with a lot of data or not very much. I think that there's a visualization aspect to looking at log data that people kind of overlook. So I'll give you an example. If you deploy a new version of your Java service, like we do periodically, and you go in and you search for exception, then you can tell simply by looking at a timeline of the number of matches that you either got better or worse, right? You can very easily see. Humans have a great ability to just detect anomalies visually. So I think that one of the things that is incredibly important is to find ways to represent your data that lets sort of the system do the heavy lifting of like identifying the data and generating the visualization, while still kind of taking advantage of the fact that humans are just really good at this stuff. And I think that it's funny when you're working on a product where that is so important. What's interesting to me is that we find things that we didn't think were important that actually are. So I'll give you an example. With structured data, we let you see sort of unique values for any of the fields, right? And one of the things that hadn't occurred to any of us when we built the interface was that when you click on one of these fields, you can see, it's like an instant kind of analysis of that field. So you can see, for example, if you click on HTTP status, you get a little mini graph that shows you, and we didn't have this initially, we just had the values, but you can see immediately that, you've got your mostly 200s and maybe a few 303s and maybe a 404, right? But it's instantaneous. Like that's it, you're done, right? And you can move on with your life. And I think that that's one of those things that we didn't really expect. We just stumbled across it. And it's been 100% consistent. That's how people use that feature of the product. It's not, we thought it was there so that you could refine your search. And what we actually found was it was there so you could do a quick sanity check on something, right? So stuff like that is always fun. And I think that some of the other visualizations that we do, obviously time series graphs and pie charts and stuff like that, are just, people underestimate the power of that. I think that there's a really, really important feature of log analysis, I guess, is one way of putting it, which is that it helps you understand your system's behavior over time, right? And so, we, for example, when we were doing the development, we would see these big spikes in, what was it? I can't remember. Let's call it latency. We would see big latency spikes in our pipeline, and everyone would like run around, like clump around the terminal and say, what's going on, right? But when you look at it over time, what we saw was that the spike happened on the hour, every hour, and it was because of a background job on the box that we were logging from, right? So without being able to see, the last day or the last week or the last month and see the pattern, those things can sort of trigger behavior that is like it was then, completely the wrong behavior. Like we were trying to diagnose a problem that didn't exist, in the sense that we thought it was much more serious than it really was. And if we had simply looked across time, we would have said, okay, it does that. Now we have a problem, but it's not as serious as we thought it was because the system always recovers. And we know exactly when it happens, so we can sort of do a much better job of diagnosing it, right? So again, it's one of those things where if you can get a feel for how your system behaves based on sort of graphs, trends, however you want to think of them, then as someone who's responsible for the system, you end up feeling a lot better about it, right? And everyone's seen traffic graphs over sort of daily cycles and weekly cycles and holiday cycles and all of that kind of stuff. The reason those things are as powerful as they are is that you can look at them and intuitively see, oh yeah, that's the weekend. Oh yeah, everyone sort of wakes up at 7 a.m. on the East Coast and goes to sleep at midnight on the West Coast, and that's why that's bigger than the other times. So, those kind of things seem trivial, but if you and to a certain extent they are, but I think that if you have the ability to see those things in data that you have previously not been able to see it in, which by and large is what happens with most log data, by the way, is mostly it's like you're looking at it through a pinhole, and because it's really hard to look at it any other way, once you start seeing it that way, it kind of changes the way you think about your system. So I think that it's incredibly...
All that information was there all the time. We didn't have a good way to get it quickly and reliably.
Exactly. It's kind of like the dark data that's lying around all over the place. And, it's not just logs. It's all sorts of stuff. So, yeah.
If listeners would like to learn more about logging, do you have any recommendations where they should read?
There is a really good book, the name of which escapes me.
You can put it in the show notes. You can tell me.
Yeah. There are. There's a lot of information available on our blog and on our competitors' blogs. I think that there's a lot of good stuff in the Logstash community, which we haven't really talked about, but I think it's probably the biggest open source community specifically about logs.
If listeners would like to find out about Loggly, how can they do that?
Loggly.com. So Loggy.
That's easy.
Yeah.
Do you personally have a blog, Twitter, or anything you'd like listeners to visit?
So we have a blog at Loggly, so it's just loggly.com/blog. And yeah, we love to have people come read. So
great. Well, Jon Gifford, thank you so much for speaking to Software Engineering Radio.
Thank you.
For Software Engineering Radio, this has been Robert Blumen. Thank you for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more information about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can write comments on each episode on the website or write a review on iTunes. Mention or message us on Twitter at SE Radio, or search for the Software Engineering Radio group on LinkedIn, Google+, or Facebook. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under the Creative Commons 2.5 license. Thanks again for your support.